Hey, MMT followers, Christina Fuges with MoldMaking Technology, and I am back with another quick MMT chat. And today, my guest is an Editorial Advisory Board member, but he is also a lecturer in the Plastics Engineering program at Penn State Behrend, and it is Nick Vitelli. Hello, Nick.
Hi, how you doing today, Christine?
Good. How are you?
Good, thanks.
All right. So again, you are a lecturer in the Plastics Engineering program at Penn State Behrend. For those who don't know exactly what a lecturer is and what they do, can you explain that?
Sure. Yeah. So most of my time is spent teaching courses here at Behrend in the plastics program. And like all faculty members, in addition to teaching, I advise students. So advising from a college career path standpoint. So making sure they're taking the right classes at the right times, so that hopefully in 4 years when they're done, they have all their requirements for graduation. In addition to that, I advise student groups in our senior project course. So that's a capstone program that all plastics students go through, and they work with industry-sponsored projects. They're generally very low cost to the industry, and it might just be something they want to learn more information about or have some experiments run on some facet of their business. And the students compile all that information and they publish their findings in whatever the topic is. Projects can range from materials, and some examples I give you. We have a group is doing a study on additive packages to blow molding grade HDPE to evaluate how it retains properties after like 3 or 4 generations of regrind. Okay. So those sorts of things that are industry, interest there. I have a design group working on a plastic tray that holds components that a electroplater has to load into their trays for plating purposes, and it's time consuming to have an operator do that. So they're looking at a tray that will have them kind of come from the manufacturer ready to just be loaded all at once into the tray system. Okay. And then we even have a project that a mining company contacted us about, that whatever material they mine, they don't use this talc in their product, but talc filled plastics, there's a large application in the industry for that. So they want us to tell them, hey, is our talc viable to sell to material suppliers and have them compound into the plastic? Will it work? Does it have the same properties as their standard talc filled, wherever they're getting their talc from now? So that's kind of the range of the types of projects that the students do in our capstone course. I guess the long story short there, I advise, I have so many groups that I advise every semester on that.
I love the wide range for not just for you, but for the students. Like there's so much opportunity, and just to keep that, I guess, the excitement, or keep them engaged.
And you'll find that's going to be a common theme today for most of my answers, just because we do so many things. So, and even, in addition to that, I work on research projects that are company sponsored, that involve faculty and other research professionals. So something that's a little more than a senior project, probably. We work sometimes with startup companies that have an idea, they want to get to market, and is this feasible? I work with those as well, with other faculty members, and sometimes those involve undergraduate students as well. Those are faculty led, and then undergrad students do paid research, so they get paid from the companies for the research they're doing on those sort of things.
That's motivating.
Yeah, definitely.
Yeah. So what a little known fact, or maybe not so little known, is the founder of MoldMaking Technology is actually one of the founders of the program there, Joe Prishak. So it's kind of a nice tie-in. But there aren't that many programs, right, in the country nowadays, but there are others. It's a pretty renowned program. When you say Penn State Behrend, that means something to people in the industry. But according to you, what does make it special? Is it this project-based, hands-on industry experience, or what? Tell me about that.
Yeah, I mean, that's one of the things. This was a tough question for me to get some answers to, because there's so much to it. But like I said, I'll go back to what you mentioned, probably the breadth of what we expose the students to. That's probably the biggest thing. Our curriculum here is pretty rigorous, but we have the largest processing lab in the country for undergraduate students. It's just over 10,000 square feet. So there's a lot of space for them. And they get exposed to, most of the courses start with injection molding. They learn about design of experiments, how processing changes affect parts. You know, they have classes in design where they have to design both parts and molds. They take courses in heat transfer and rheology to understand how plastic flows, advanced tooling concepts. And again, we cover thermoset, injection blow molding, extrusion blow molding, thermoforming, blown film, cast film. So we have equipment to allow them to experiment with and touch all those processes, which I think is very valuable. And one of the more recent programs here is the Polymer Engineering and Science that we just started 4 years ago. And that has really increased our capacity in the material side. Testing, we just got it actually 3 weeks ago. We installed a high-speed impact tester. So we can test plastics at impact test at high speeds and control temperature, humidity, all those things. So it's very interesting to see the testing side, how advanced it is here. We have FTIR, TGA, DSC machines. So those are all just acronyms for very high-end testing equipment for specific to polymers. So it allows students to look at, you know, the properties of the resins, you know, how the plastic materials crystallize if they're semi-crystalline, all that equipment we have, you know, which is millions of dollars worth of stuff in general. And other universities that might have those pieces of equipment, only graduate students are having experience on those, and we give that experience to our students at an undergrad level, which I think is another thing that makes us unique. Sometimes things get broken, but that's the price you pay when you're learning.
That's right. Exactly.
One of the recent grads I talked to mentioned this, and he said it was faculty. So we have a pretty low faculty to student ratio. So there's a lot of interaction between students and faculty, and all the faculty have industry experience, but in different areas, right?
Okay.
So my background being mold making and design, a faculty member that sits across the hall from me, he had his own part design company for many years, a consulting firm. So his expertise is in part design. Some of the faculty came from, you know, industry at 10 years as process engineers. So they have a lot of processing experience. We have faculty members that were composite specialists in the aerospace industry. So the breadth of what our faculty experience in industry is, I think it makes a huge impact on the students, and it goes hand in hand with the different courses that are all the topics we cover in the plastic. And then probably the last item would be the students. We have a pretty diverse background of students from a standpoint of their motivation for being here. You know, some are just interested in designing things, like most pre-engineering type kids. Others, you know, really love running the equipment, making parts, right? But then we have others even that are really interested in sustainability and how they can make a difference in the responsible use of plastics, which, you know, that's something that we talk about all the time, and we know that it's something we all need to find a way to get better at. But how do you do it? You do it from inside, you know, and some of this research activity we have going on, especially when we talk about all those fancy pieces of equipment that can analyze materials, is, you know, how can we develop the next generation of biodegradable polymers, and how do we get the requirements out of those resins that we need for what types of products we're designing and building, right? So all those things kind of go hand in hand. And
I love that you're attacking that sustainability, because you're right. Everybody talks about it, but you're actually teaching them and giving them an experience of what their role could actually be in developing products under the umbrella of sustainability. So I think that's wonderful, and not surprising that that's something that's attracting that next generation.
Exactly.
Yeah. All right. So let's go back a little bit and hear about you, because your experience, which, you know, of course, is of interest to me, being mold making technology, is your mold making and mold design background. So give us a little snapshot of where you came from, and then why you made the jump to education.
So I'm a graduate of the plastics program here at Behrend. It's pretty rewarding now to be a faculty member. That's an exciting, sometimes surreal thing for me. But you know, when I was I think between my sophomore and junior year, I started at a tool shop as an intern and stayed on, you know, after I graduated, which is pretty common. Most of our students pretty much by their senior year know where they're going to go, just because we have it kind of goes to some of what we were talking about before, is plastics in general, in the greater, community, I'll say, kind of have a bad rap for PR right now, right?
Yep.
So it's tough to, we can't graduate enough students for how many jobs there are out there.
Oh, of
So
course.
generally, once our students get into an internship program, then they get,
They get a job.
But so that was my path too. I worked in, I started out as a tool designer, worked through in project management. The company I worked for served many different industries. So we had consumer products, customers, automotive, medical, thermoset, and even die-cast work we did. So I got to see a large cross-section of tooling, and the way different subsets of, I'll say, the mold making industry do things.
Yep.
So that's one of the things I'm always trying to pass on to my students is, I spent a lot of time working with customers on the front end, quoting projects, talking about, design for manufacturing, things like that. So the relationship value there was always very important, and how you can have a positive impact on your customers. The earlier you can get, any mold making people involved in a project, it just, the project's going to go better because you can see
right.
the types of issues that they can run into. That's kind of my background. It was probably a couple of years after graduation, an opportunity came up to teach like in the evening here at Behrend. And I had 3 little kids at the time. So I thought, well, it's a good way to make a few extra bucks. My wife wasn't working. She was home doing the at-home mom things. So I started out at doing that, and I didn't really realize how much I would enjoy teaching. It was rewarding. And I thought, I don't know, maybe someday I'll do it full time. And it just kind of worked out that way.
Did it seem natural to teach?
Yeah. I did. It was just, I don't know, it was enjoyable. And I think that part of that is how much I enjoy the everything about plastics, but specifically for me, mold design, mold making.
Were you specifically teaching mold design?
I started out teaching a intro to CAD design class. Yeah.
Now, that aspect teaching, what is the best part of that aspect of your job?
Yeah, I would say it's definitely when you see a student make that connection, like it clicks for them, that they understand a concept, whether it's something complex or whatever. It's just rewarding to see them make that connection and go from what they read in books and theory, and actually being able to see the application of that in the real world. Yeah, that's definitely the most rewarding portion of
that light bulb goes off, and you're like, I got one.
Moment. Yeah.
Right. What is your impression of the students today? You think everybody gets labeled, right? And everybody says this generation is that, kids this. What is your impression of the students that you encounter?
They're definitely different than my generation and generations before me. When I was in school and then, transitioning into work, there was kind of that understood hierarchy, and that still exists, I think, in tool shops to this day. And the feeling of, you're the new guy, you got to pay your dues, and then eventually you work up to having a spot where you can make a difference. The students today are really passionate and interested in making a difference right away, so they have different priorities, than my generation did, for sure. So finding a way to understand that, make sure they know they're making a difference, that's probably the biggest thing we can do as, I'll say, not want to say older people, but
seasoned. I like the word seasoned.
That's a good, I like that word. Helping the younger people coming into the industry.
It's funny because I think of all different types of jobs, but when it comes to manufacturing, once they see that, whether it's mold making or plastics or what, machining, a job shop, once you see like what you're making, you would think it would be immediate. Once you make that connection, like, oh, I'm not just pressing a button and this product pops out. Like you should, I don't know. There's not that many jobs where you get that immediate feedback in terms of your profession.
Exactly.
So it's always it amazes me how long it takes sometimes for people who don't know manufacturing.
Yeah.
Right. Once you get them in that program, I would think it doesn't take long for them to see that, to have that light bulb go off. Like this is going to be meaningful. Now, do you think our generation, when you say making a difference, and we do say that a lot about the younger generations,
right?
Do you think that we in manufacturing, we didn't feel that way about our jobs? We didn't care.
I don't think it was that. I think it was just like I said, the culture, maybe, and it's more of a culture shift.
Tell me if this is true too. In a traditional, I'll say mold making, a traditional mold building facility, it's not every day that you're going to have degreed engineers coming in. So not only
Right.
do you have that coming in, they're also younger. So
Yeah.
that's tough too for the
Yeah,
seasoned
it is.
guy or gal to accept those
Yeah.
ideas, right?
Yeah. Like I said, that's why it requires compromise, from both sides,
Yeah.
realizing that the goal is working together. That should give us
Yeah.
the best path forward, right?
Yeah. Is that something that you address in your programming at all with the kids?
I do.
The
Yeah.
soft side, yeah.
Yeah. Anecdotally, during lecture, I'll talk about that and talk about, hey, you might have a project and you've got a very seasoned guy who's got 40 years experience in processing. You're not going to just go in there and say,
Yeah.
you're doing this wrong, do this.
So speaking of that,
Yeah.
when you think of your program and other programs or the educational system in general, what do you think is lacking in the educational setting, when it comes to really graduating and getting future mold making plastics professionals in the marketplace?
Yeah. I mean, the biggest thing I can think of, the knowledge that's required. Like we talked about, you have people in industry that have had years and years and years of experience, and it's really hard to cram all that down into the amount of time we have to talk about things, especially, from a mold making standpoint. It's a 4-year bachelor's degree program, but there's so many topics we cover that you can't, how many years does it take to be a good mold maker or tool maker? I mean, it takes years, right?
Exactly.
So we're doing some things here to try to address that as far as developing some new certificate programs in our PLET program for mold design specifically. So, like I said, the students get part design and mold design classes, but you get a semester to say, hey, we're gonna design a mold this semester. So here's the process. Here's how you do it. That's not enough time to be an expert at it by any means.
No.
So we're hoping that expanding that in our program here as a offering what we call tech electives. So once you get into your junior and senior level classes, you have a little more leeway, where the majority of your courses that are required for the 4-year degree are complete. So now you can kind of specialize in what you're interested in. So we have some in advanced processing, medical, specific to medical processing. And like I said, we're developing some for mold design as well, so that we can get them more advanced techniques, get them designing and looking at more complicated molds. So I hope that helps for sure. But you still have to have the right students that have that mindset of going into a tool shop. You're still going to be learning, just because you just can't cover all of that material in a 4-year program.
No, you just can't. So. You're right. It's a lifetime. And with the way technology and processes, the advancements happen, it is a lifetime. But you hit the nail on the head, because I know you and I have spoken virtually about this before, but for the longest time, it was, the lack of skilled labor in manufacturing in general. And then even within mold building, now it really is specifically mold designers and engineers. There is a desperate need for them. So you're hitting it with, we need to focus on that aspect of the industry and get those guys and gals out in the field. Does that tie into this manufacturing center that's under development?
Yeah, it does. It does somewhat, for sure. Yeah, we're working on a new manufacturing. I think it's Center for Manufacturing Excellence is what we call it, or manufacturing competitiveness, maybe. I don't know. The name changes a little bit, but it's a new facility here that Penn State is pushing forward with some of the local industry we have here. Obviously, Erie's pretty high concentration of plastics molders. There are tool makers, or tool design, mold making companies around here, and some heavier industry. We still have the GE Transportation, the old GE Transportation. They were sold now to it's Wabtec now, I think, but where they make the locomotives is 4 miles from here, 3 miles from here. So there's a large push in that. A component of this new building is going to be a sandbox for companies to come in and experiment with newer technology. One of the things on my short list to get into that facility is 5-axis machining. So there's still lots of tool shops that there's a cost to entry barrier there for them. So giving them the access to that piece of equipment to say, come in, play with it, try it, see what you think. You know, does this make your standard thing you do every day? Is it easier? Is it faster? Then they can work on ROI type things for themselves and see, you know, how they can drive themselves forward from a technology standpoint, you know.
That's fantastic.
Or you know, molding with you know, robots, you know, does it help? How do you interface with robots? How do you get that to close that gap for, you know, to help with some of, like what we talked about, some of the staffing issues that molding companies have, and not being able to find enough people, you know. So some of the jobs at least can be replaced by robotics. So
Exactly.
does it make sense? How does it work, you know, for
Yeah.
people that don't have them, giving them access to that?
How do the students play into that manufacturing center, or how are they going to?
Yeah, the students, you know, here Penn State's mantra in general is an open lab setup where we want our students to have access to everything we have, because the more they can touch and play with and look at, the more they learn, the more they may find a segment of the industry that is really interesting to them that they may not even have thought of, you know.
Yeah.
So it will definitely be something that we find a way to have the students a part of, so that they can see what's going on. And in addition to that, if we have companies coming in, industry coming in, anytime we get students with industry is great, because they get to meet and shake hands with people that are working or you know, at companies local or not. I mean, any companies that come in here,
That's true.
it's good anytime we can get the students face to face with them. It helps them with, you know, building their networks, and they start to realize how beneficial that is.
So last but not least, let's talk about the future.
Yeah.
And it's a perfect question for you since you're in education.
Yeah.
There's been a lot of talk about how the role of the mold builder has changed and continues to change. So when you think about the future, what does the mold builder of the future look like to you in terms of the characteristics they need, the skills, their qualities? What do you think?
Yeah. The thing that really kept sticking in my mind when I was thinking about this question was problem solving skills. So, you know, many industries have that issue right now of having enough employees, right?
Yep.
And employees they do have, you know, not every one of them is willing to think outside the box to solve issues. You know, sometimes they want a list of tasks to say, here's what I'm responsible for. This is what I do, you know. But from a mold building standpoint, at least my experience was, you know, it's not that straightforward.
Yeah.
During design and build of molds, there's lots of things that come up that require dynamic problem solving skills. So, you know, timelines we know are more and more compressed. You know, that's one of the biggest ways that I saw domestic tool makers were able to compete with overseas was, you know, cost was less of an issue. It was more the timeline time, right? Getting tools built quicker, getting parts into production faster. And that comes from the companies, you know, that are making the products. They're not giving the molders much time to get the molds built and they want them it's like when they make that decision to cut the check, they're like, okay, when are we sampling the mold? You know?
Yeah, exactly.
So sometimes you know, you're starting mold designs and starting manufacturing on molds when the part designs aren't even frozen yet. You know, they still aren't really sure about this one feature. We're still doing some testing. You have to prepare as best you can for changes that might come up and build into your tool build timeline program, you know, ability to adapt. So I think that having those skills is probably, you know, one of the biggest that will be beneficial to people working in the industry in the future.
I agree. All right. Well, on that note, Nick, thank you so much for your time and giving us a little glimpse into yourself, your background, and the program at Penn State Behrend.
Absolutely. Thank you.
All right. And for everybody out there, for everything mold making, visit moldmakingtechnology.com. Stay informed and stay inspired.